In this video, I'm going to show how you can use the CP62 current probe to simultaneously measure both voltage and current of a circuit. A benefit of using a current probe instead of like a bench multimeter is that you don't need to break the circuit in order to measure current. You clamp the current probe around one of the supply wires or any wire that would be in the circuit, and you're able to measure the circuit's current. With a bench multimeter, you actually need to put it in series and break the circuit in order to make your measurement. Another benefit of using a probe is that you not only are able to measure the current value like you would with a meter, but you can also see the current waveform. So to illustrate this application, I've got a function generator here outputting a basic sine wave through a little simple circuit. I've got the multimeter in series, and the 2559 oscilloscope. I've got channel 1, which is the yellow trace. It's measuring the voltage from this probe across the capacitor, and the channel 2 is the blue trace, and that is measuring the output voltage from the CP62 current clamp. It is measuring 12 millivolts, and you can see here I've got 126 milliamps. So the way the CP62 works is you've got 100 millivolt per amp or a 10 millivolt per amp setting. So the 10 millivolt per amp is for measuring larger currents, and the 100 millivolt per amp is for measuring smaller currents like we've got here. So if I've got 12 millivolts being measured, and I've got it set to 100 millivolts per amp, that's telling me I'm measuring 120 milliamps. So if I was measuring a current value that was even less than what we're measuring here, like around 60 milliamps or whatever it might be, one little trick you can do with current probes is you can go ahead and make loops, and then it will multiply the value that you're measuring. Need to adjust this. So now I've got 36 millivolts. I've got 3 loops, so that would be, divide that by 3, you've got 12 millivolts. So again, it's telling me the same value, but it's really helpful if you're measuring something a lot smaller, even down to like 50 milliamps or even less than that, like 10 milliamps. You could do it 5 times, and you would then measure 50 millivolts on here, and then you would divide by 5, and you're able to get your actual current value. So one other benefit that I mentioned earlier is that you're not only able to measure the current of the circuit, but also actually see the waveform, the current waveform. So what I'm going to do is I'm going to take the signal generator and change it from sine wave to some arbitrary waveform, which in this case happens to be like a stepped ramp waveform. So on the multimeter, it has changed the amount of current to around 117 milliamps. And on here, I can see I've got around 10.8, which is about almost 111 milliamps. But you're also able to see the waveform. And sometimes that's going to be telling as to when you're troubleshooting what could be wrong with the circuit or what's actually happening. So that about does it for this video. Please feel free to leave comments, and thank you.